Good morning, dear students. My name is Ferhan Mazher, and today is 1st April 2021. Right now, I am with the O3 class. Subject we are studying is Physics 5054, and today we are going to solve October-November 2011 and 2-1 paper. And in this paper, we will be one thing I have not written here. We will be attempting only the section one, section B. Section A of this paper we will be attempting in another session, but in this session we will be working only on the section B of October-November 2011 2-1 paper. It's a paper from the zone 1. For zone 2, the zone 2 papers, they are in the red spot. So the strategy is that you will be doing the paper zone 2 papers from the red spot. From there you can get the help, and zone 1 papers, paper 2s, I will be doing and posting the videos. So if you are following us on the YouTube, it will be very good practice, and we hope you will get the best grades possible. Okay, so let's start today's paper. And so this is October-November 2011 2-1 paper, section B we are going to attempt. Okay, so section B is on your screen. He says question number 9, figure 9.1 is the speed time graph for a rocket from the moment that the fuel starts to burn at time t equals 0. You see, if you look at this graph carefully, you will see that this is a speed time graph. The time is in seconds, the speed is in meter per second, the speed is represented on the y-axis, the time is represented on the x-axis. So it's a speed time graph, and you know the distance traveled will be the area under the graph, and the acceleration at any point will be equal to the gradient of this graph. So these are the very basic things which you should know about the speed time graph. So the time is 0, you can see the speed of the rocket is 0, and the speed of the rocket remains 0 up to 1, 2, 3, 4, almost 5. So it means up to 10 seconds or up to maybe 8 seconds, the speed of the rocket was 0. And then it started accelerating. And you can see here the graph is curving upward. It means it's an increasing curve. And I told you that the gradient of this curve is increasing, and the gradient of the speed time graph is equals to acceleration. So you see here the gradient is gradually increasing. So it means the value accelerates. The speed no doubt increases, but the acceleration value is also increasing. So here the acceleration is increasing and it's non-uniform because the graph is a curve. And up somewhere here the graph has become a straight line. The gradient of the graph has become constant, which means now the velocity is no doubt increasing, but the value of the acceleration, that has become constant. Now you can say it's accelerating with a uniform acceleration. So when the speed time graph is a curve, it means that the acceleration is not uniform. And when the speed time graph is a straight line with a constant gradient, it means the acceleration has become uniform, or the acceleration has become constant. Another important thing is, at the start you see the graph is flat. From 0 to I think 5 or 8 seconds, the graph is flat, horizontal. When the graph is flat, it means the acceleration value is 0. So these are the few things which you should know before going into the question. So let's start. The first question is, state the principal energy changes taking place as the rocket accelerates upward. So the rocket is accelerating upward. So it's very important sentence. He says it's accelerating, the rocket accelerates upward. So the rocket is going upward and it's accelerating. You know, the rocket has fuel, and the fuel has the gravitation, the chemical potential energy. And so that at the start we have the chemical potential energy, then that fuel burns. So the thermal energy is given out, and that due to that thermal energy or the hot gases which are produced, the rocket is pushed upward. So the kinetic energy, that the thermal energy will be used to produce kinetic energy, and the rocket will start moving upward. So when the rocket will gain height or altitude, so the rocket will be its gravitational potential energy will be increasing. So you have the chemical potential energy that converted into the thermal energy, and that converted into the kinetic energy of the rocket, and that converted into the gravitational potential energy of the rocket. It's a 4 mark question. Let us check the marking scheme. Let's check the marking scheme, and then we will see what we can do. This is question number 9, section B. He says that the question is of 4 marks. Let me, yeah. Now the marking scheme is showing on your screen. There are 4 marks, and at the start there is chemical potential energy. At the end we have the at the end we will have the gravitational potential energy. At the end we will also have thermal energy, or we call it the heat energy or internal energy. And somewhere in the between you should mention the kinetic energy. So this is the marking scheme and the distribution of the 4 marks. I have written this on my on a paper. Let me show you my answer. Let the answer show. Yeah. At the start, fuel has chemical potential energy. It converts into thermal energy, and thermal energy converts into the kinetic energy of the rocket. Final form of the energy will be from kinetic energy into the gravitational potential energy. It's a 4 mark question. Muskan, can you write this answer in your booklet?
Yes, sir.
So kindly write. This is showing on your screen. I have shown you the marking scheme also. Kindly write your answer. When you are done with your answer, kindly let me know.
Okay, sir.
So at the start, there was chemical potential energy in the fuel. The fuel started burning, so the thermal energy is given out. The hot gases pushes the rocket upward, so the thermal energy converts into the that converts into the what you say
Done, sir.
uh, that converts into the kinetic energy, and then the rocket goes up, and the rocket gains the gravitational potential energy. So very simple thing, but it is of 4 marks. Muskan, when you are done,
Done, sir. I have written the answer.
okay, okay. We are moving to the next question. The next part. The next part is state the size of the acceleration of the rocket at t equals to 0. State the size of the acceleration of the rocket at the t is equal to 0. You see here, at the time when the t is 0, you see what happened? The slope is 0. And the slope of the speed time graph, or the gradient of the speed time graph, that represents the acceleration. So at the time t equals to 0, the value of the acceleration will be 0. It's a 1 mark question. Muskan, do you understand?
Yes, sir.
Okay. Then the next question is state what happens to the acceleration of the rocket between t is equal to 5 seconds to t is equal to 80 seconds. So t equals to 5 seconds and t is equal to 80 seconds. Look at the graph carefully. So this is the time t equals to 5. And from here, you see it has started accelerating. But the graph is a curve, so it means the acceleration is non-uniform. And then it becomes a line which has a constant gradient, which means that the acceleration has become uniform. So it means that at the start the acceleration is non-uniform, and then the acceleration becomes uniform. I have written this answer. Let me show you my answer. So here Here you can see on the screen we have 9B first part, acceleration value is 0, and 9B second part, from 5-second acceleration starts increasing non-uniformly. After 50-second acceleration becomes uniform. Muskan, do you understand this?
Yes, sir.
Okay. So you can write this answer. I'm showing you the marking scheme, and on your screen we have the marking scheme. The acceleration is 0, B first part, and in the second part, 1 mark is for telling that it increases, and 1 mark is for telling that as then it becomes constant value. So acceleration at the start is non-uniformly increasing, and at the second step, it becomes constant. So hope you are able to write. Have you written your answer?
Yes, sir.
What you wrote? Would you like to read?
Yes, sir. At start, acceleration start increasing non-uniformly, but after 50 seconds, acceleration became uniform.
Yes, 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 yes. Hello?
Yes, sir.
Okay, you were reading your answer.
Yes, sir.
Okay, we are moving to the next question. Calculate the acceleration of the rocket at t is equals to 80 seconds. Calculate the acceleration of the rocket at t is equals to 80 seconds. Let's go to that graph and we will see. You see, let me increase the size so you can see it clearly. So now what we will do, we have, this is the point where you want to find out the gradient. So you can take 2 points on this straight line. Note down their coordinates. For example, I take this point. This point is 60, comma 600. And suppose I take this point and this is 80, comma 1000. So in this, on this straight line, you can take any 2 points and note down their coordinates. Then I will use the formula for the gradient. The formula is y2 minus y1 divided by x2 minus x1. You must have learned in your mathematics class how to find the gradient of a line if 2 points are given. Y2 minus y1 divided by x2 minus x1. You will find the gradient, and that will be the acceleration. I have done this on a paper. Let me show you my work. So the question is, what is the acceleration of the rocket at 80 seconds? I've done this work. Let me show you my work. Yeah. So this is, let this show up on the screen. Okay. So you can see I have taken 2 points, 60, comma 600 and 80, comma 100. And then I apply the formula for the slope, for the gradient, y2 minus y1 divided by x2 minus x1. 1000 minus 600 divided by 80 minus 60. 400 divided by 20, and the final answer will be 20 meter per second square. Are you done with this?
Yes, sir.
Okay. So let's check the marking scheme as well, if our answers are right. Okay, so on your screen you can see that the answer is perfect, 20 meter per second square. Let's move to the next part. So give me a minute because there is a problem. Okay. The total mass of the rocket at T is equals to 80 second is 1.6 x per 6 kg. Calculate the resultant force on the rocket at this time. I know the mass of the rocket now. I know the acceleration which is produced in that rocket. So I can find out the force, resultant force which is producing that acceleration. I can use the Newton's second law of motion, is mathematical form. F is equals to ma. F equals to ma. I know the m value. I know the a value. Simply put those values in that formula and you will find the resultant force. I've done this on a paper. Let me show you my work. And here we go. So on the screen, you can see F is equals to MA, F is equals to 1.6 x per 6 multiplied 20, and the final answer on your calculator will be 3.2 x per 7 Newton. 3.2 x per 7 Newton. So let's check from we can check it from the marking scheme as well. So let's check the marking scheme, what the marking scheme says. And the marking scheme says final answer will be 3.2 x per 7 Newton. 3.2 x per 7 Newton is the final answer on the marking scheme. Okay, so now the next part, the fifth part of this question, the total weight of the rocket at the T is equals to 80 second is 1.6 x per 7 Newton. Calculate the upward force on the rocket at this time caused by the burning fuel. So if you want to find out the total upward force, the total upward force has to overcome the weight plus the force required. It has to provide the force required for acceleration. The force required for acceleration, we call it the resultant force. We have just done that. We have calculated that thing. So the upward force will be equals to the resultant force plus the weight, because the upward force need to overcome the weight and has to provide the force for the acceleration. I have done this on a paper. Let me show you. Okay. So on your screen, it's showing that the upward force should be equals to weight plus the resultant force we just calculated. And that will be 1.6 x per 7 plus 3.2 x per 7. And the final answer will be 4.8 x per 7 Newton. 4.8 x per 7 Newton. Let's check from the marking scheme, what the marking scheme says for the B fifth part. The marking scheme for the B fifth part is 4.8. The marking scheme is showing in a minute in front of, and yeah. Now 4.8 x per 7 Newton is the final answer. So it's good. So let's go to the next question, next part. Muskan, do you have you understood this?
Yes, sir.
Okay. So we are moving to the next question. He says C part. Question number 9, C part. As the rocket burns fuel, it ejects hot gases downward. The question is, the first part, state Newton's third law of motion. Newton's third law of motion, very famous law. We have to write its statement. It's a 1-mark question. It says every action has a reaction. Action and reaction are equal in magnitude but opposite in direction. This is Newton's third law of motion. Very famous statement. I have written this statement on a paper. Let me show you what I have written. Every action has a reaction. Action and reaction are equal in magnitude but opposite in direction. This is Newton's third law's statement. The action and reaction, they act on different bodies. This is also very important, but this is enough for 1 mark. Muskan, have you written this answer?
Yes, done, sir.
Done. So let us check from the marking scheme. See, first part, the marking scheme says To every action, there is an equal and opposite reaction. For the forces acts in pair or equal size and in opposite direction on different bodies. On different bodies is also very important statement. Explain how Newton's third law of motion applies to the upward force on the rocket and to the force on the hot gases. You see, when the hot gases are produced in the rocket, so the rocket applies force on those hot gases and those that's action, and the hot gases will apply force on the rocket, and this is the reaction. So you see the action and reaction, the force exerted by the rocket on the hot gases and the force exerted by the hot gases on the rocket. Both these forces will be equal in magnitude, but their direction will be different. Plus, they will be applying on different bodies. One force is applied on the hot gases, and the reaction force is applied on the rocket. So let me, I've written this answer as well. So on your screen, I think it's showing. Rocket apply force on hot gas and hot gas apply force on rocket. Both forces are equal but opposite in direction. Their magnitude is equal, but they are acting in different opposite directions. Plus, they are acting on different bodies. One force is acting. One force is acting on the gas, and the other force is acting on the rocket. So, let's check from the marking scheme. This is the C second part. C second part is showing on your screen downward force on the gas. One mark is for this, and equal and opposite to upward force on the rocket. One mark for this. So I hope that you have understood this. Muskan, have you written this answer?
Yes, sir, I have written.
Okay, good, 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 good. We are moving to the next question. So, dear students, we are done with the question number 9, and now we are starting the question number 10. Figure 10.1 is the circuit diagram of a fan oven that works from a 230-volt AC main supply. So, look at this diagram first of all carefully. Let me increase the size so I can show you this diagram. Try to understand this diagram. So, here we have an alternating supply. The EMF of the supply is 230 volt. So from here the current will be coming. So here I have a switch. We call it the switch 1, S1, switch 1. And then here I have a junction. From here the two wires are going. One is going into the fan motor and one is going into this heater. And for the heater we have a separate switch also, S2. When the S1 will be closed, S2 is open. When the S1 is closed, you see the current will flow into the fan motor, and the fan will start. But the heater will remain off. When this is closed and S2 is also closed, then the fan will be on and the heater will be also on. So you see, it depends how this is, how you have closed. If both the switches are closed, the heater will be on and the fan will be also. Now, if you, let's say you keep the S2 closed, but you open the S1. If you open the S1, you see the supply of the live current to the heater and the fan, both will be cut off. And if the S1 is open, S2 is closed, both the things will remain off. The fan will be off, the heater will be off. So let's let me reduce the size so you can see. The question is, let me show you the full question. Yeah. The oven contains a 350-watt electric heater. The power of this heater is sorry, I said 350, 3500 watt. An electric fan operated by a 200-watt fan motor and two switches S1 and S2. When switch S1 and S2 are open, both the heater and the fan motor are off as shown in the figure. So if you see, if this S1 and S2 are open, both fan and the heater they'll be off. Now we have to complete it. So if I close S1 and keep the S2 open, if right here close and right here open. So what will happen if S2 is open and S1 is closed? The fan will be working, but the heater will be off. The fan will be on and the heater will be off. If you close S1 and you close S2, if you close both of them, then the heater will be on and the fan motor will be on. Complete the figure 10.2 by writing open or closed in the boxes. This is a 2-mark question. I have done this on a paper. Let me show you my work. So if the switch S1 is closed and S2 is open, the heater will be off and the fan motor will be on. So closed and open in the first row. And then if both of them are closed, S1 is closed, S2 is closed, the heater will be on and fan motor will be also on. So this is what you have to write in that box. We can check from the marking scheme also: closed, open, closed, closed. From the marking scheme, you can see that closed, open, closed, closed. Let's move to the next part. Explain how the circuit represented by figure 10.1 ensures that the heater cannot be switched on when the fan motor is off. The fan motor is operated by S1. If the fan is off, the heater cannot be switched on. If the fan is off, because the current for the fan is coming from the switch S1. If the S1 is open, then the heater will automatically remain open, because the heater will be also disconnected from the live wire if the S1 is closed. If the S1 is open, sorry. So this is how the circuit makes sure that no current flows through the heater if the fan is off. Let me show you my answer. I have written this answer also. I have tried to write the answer. If S1 is open, the heater will be also off. Heater can be only switched on if S1 is closed. This will also switch on the heater. If S1 is closed, this will also switch on fan. If you close the switch S1, it will switch on the fan. And if the S1 is open, the heater can also not be open, and that the heater cannot be switched on. A little complication in writing this answer, because it's little. S1 closed, motor is on. When you close the S1, then the motor of the fan comes on. And if you S1 is open, the heater will 100% be off. This is a 2-mark question. This is little tricky because this wording is little tricky. Muskan, do you understand this question?
Yes, sir.
Okay. So let's move to the next question. He says, third part. Just one reason why the circuit is designed is so that the heater cannot be switched on when the fan motor is off. So you see, whenever this heater will be on, the fan will be also on. Whenever this heater will be on, the circuit is like this. Whenever the heater will be on, the fan will be also on. Why they have done so? You just have to suggest a reason. We think that the heater is there so that the heater, when the heater is giving, heater means that it's giving out heat. And what the fan will do, it will take away that heat. So it will prevent the heater from becoming too much hot by the circulation of air. So the fan will take away the heat produced by the heater. So it will prevent the heater from overheating. Another way can be that this fan is used like it might be an oven, or and that fan is taking the heat to away. So you can put the things on that fan and you can cook them. I've written this answer. Let me read the question again. So just one reason why the circuit is designed so that the heater cannot be switched on when the fan motor is off. So I have written this answer also. Let me show you my answer. Okay. So on your screen, it's not yet showing. Okay. Now it's showing to it prevents the overheating by taking the heat away by circulation of air. It prevents the overheating by taking the heat away by circulation of air. So you see, let me show you another thing. Yeah, we need to see the marking scheme. Yeah. The marking scheme for the 10A third party says the heater would overheat, burn, or melt, or more efficient cooking circulation described. So by putting the fan, if this you are using this thing for cooking, by the circulation of the air, the heat will reach your utensils. So you can write this answer. Muskan, have you written this answer?
Yes, sir.
What you wrote?
I wrote that this prevent the overheating by taking away excess heat and by circulating air.
Yes, it's right answer. Good. Now question number 10B, first part. The sorry, yeah, the heater and the fan motor are both switched on. The heater and the fan motor are both switched on. Calculate the current supplied to the oven. You know about these, we are talking about this circuit. And in this circuit, I know two things. I know the power of the heater and the fan, and I know the EMF of the supply. The power of the heater is 3500 watt, and the power of the fan is 200 watt, and the EMF of the supply is 230 volt. Now you see the total power of this circuit will be 3500 plus 200. The total power of the heater and the fan, 3500 plus 200, that will be 3700. I know the EMF of the supply, I know the total power. You remember the formula for power is IV. The power formula is power equals to I multiply V. So I know the V means voltage, that is 230 volt. The total power is 3700 watt, and easily I can calculate the value of the I. This is the question we are doing. The heater and the fan motor are both switched on. Calculate the current supplied to the oven. So I have done this on a paper. Let me show you my work. So we are talking about question number 10B and its first part. So the total power will be the power of the fan plus the power of the heater. That will be 200 watt plus 3500 watt. So that will be 3700 watt. And we know that the power is equals to IV. The total power is 3700 watt, and the value of the I want to calculate. The V value is 230 volt. So if I make I the subject of the formula, so 3700 divided by 230, and the final answer will be 16.1 ampere. So, question number 10, B, first part. Bete, kindly complete this question, this part. Are you done with this numerical?
Yes, sir, I have done this.
Okay. And you understand it
Yes,
also?
sir.
Do you understand?
Yes, sir.
Okay, good, good, good. Zainab is also with us. Now, let's check the better marking scheme. What the marking scheme says. You see on the screen, B first part, the marking scheme is showing the final answer of the B first part will be 16 ampere. We also got the same answer. So we are good. Okay. Now let's start the next question, next part. It says suggest a suitable rating for the fuse to be used with this oven. You see, your oven is taking 16.1 ampere. So the rating of the fuse which you will use that should be little higher than the 16.1 ampere. It could be 17 ampere, it could be 18 ampere, it could be 19 ampere, it could be 20 ampere, it could be 30 ampere, up to 40 ampere. You can name any number because the rating of the fuse should be higher than the current which that machine normally takes. Our oven is taking 16.1 ampere, so the rating of the fuse which you will use for that oven should be any value which is more than 16.1 ampere. For example, I might say use 18 ampere. You might say 20 ampere. Both these values are good. You can write any number more than 16.1 ampere. You understand this?
Yes, sir.
Do you understand? So what you have chosen? What you chose?
17
18
ampere.
ampere.
18.
Okay. So let's see what I have chosen. Oh. So I have also chosen 18 ampere. I have also chosen 18 ampere. The next question is, let me show you because that is not that fast today. So the next question is the fuse is placed in one of the three wires in the mains lead. State the wire in which it is placed. You see, from the main we have
Light
three
one.
wires. We have the we have the live wire, we have the neutral wire, we have the ground wire or the earth wire. So the fuse is always placed in the live wire. Don't forget this thing. The fuse is always installed in the live wire. Okay. Now let's move to next question. And this is the B third part. He says explain. He says explain how the earthing the metal case of the oven makes it safer. You know, this question comes many times in papers. That how when you connect the earth wire, how this make the things or oven safe. Try to understand this thing. Can you connect the earth wire with the metal casing of the oven? It's a safety measure. How? That's the question. If by chance, if by chance the live wire comes in contact with the metal casing of the oven, the metal casing of the oven will also become live. 230 volt in it. That is very dangerous. Anybody touches that oven will be electrocuted. Now, if you have connected an earth wire, the resistance of the earth wire is very low. So the current will start going from the body of the oven into the ground. Due to this, the current which is coming from the main supply, because now the current is going to the oven heaters and fan, plus the earth current is going through the ground wire into the ground. Now the current coming from the main supply will increase. When there will be a surge, there will be an increase in the current coming from the main supply. You see what will happen? the fuse which you have put in the live wire, it will overheat and it will blow, and it will cut off the supply of the live current to the oven, and your oven will be isolated from the live current, and now it will be safe to touch and repair. You see, this is how the earth wire and the fuse, they will be making the oven safer. I have written this answer. Let me show you my answer, and then we will see. So on your screen it is showing, if metal case comes in direct contact of the live wire, metal case will become live. Through earth wire, live current will be directed to the ground if an earth wire is connected. Through the earth wire, live current will directed to the ground. This will increase the supply of current from main supply. This surge of current will blow the fuse. Oven will be cut off from the live current, and it will be safe to touch and repair, and there will be no danger of the electrocution. You can write this answer.
Yes, sir.
Okay, let's check the marking scheme, what the marking scheme says. Marking scheme says there are 3 marks for this question. 1 mark is for saying if case becomes live or live wire touches case. 1 mark is for saying the fuse will blow. And 1 mark is for saying that the live supply is disconnected. Case is safe to touch. It prevents the shock. It prevented electrocution. Are you able to write this answer, Muskan and Zainab?
Yes, sir.
Have you written your answer?
Yes, sir.
Would you like to read it?
जी सर रीड करूं?
Yes,
Should I
yes,
read
yes.
it?
Go on. Yes,
The
yes, yes. Okay.
resistance of the earth wire is very low. Through the earth wire, live current will be directed to the ground and will increase the supply and will blow the fuse. Oven will cut off and from the live wire, and it will be safe to use.
Okay. A little better answer is this. Uh,
And sir.
yes. You like to read your answer also,
Yes,
Muskan?
sir.
Would you like to? Yes, kindly read.
When metal case comes in contact to live wire, it will become live. Through earth wire, live current will be directed to ground, due to which the main supply of current will increase. This will blow the fuse and live supply will be disconnected and it will be safer to touch.
Yes. Live supply of the current to the oven will be cut off. Okay.
Okay, sir.
Oh, it's good. It's good. And there is always room for the improvement. Okay, next question. The next question is also of 3 marks. It says the cost of 1 kilowatt hour of electric energy is 35 cents. Calculate the cost of leaving just the fan motor switched on for 12 hours. One very important thing, and you also underline on your booklet. Calculate the cost of leaving just the fan. He's not talking about the heater. Very important thing. He's saying just leaving the fan motor switched on. It means the fan is on, but the heater is not on. The power of the fan is only 200 watts. He says calculate the cost. The calculating cost is very simple. You multiply power with time and you multiply it with the price of 1 kilowatt hour. But the power should be taken in kilowatts, not in watts. It should be taken in kilowatts. and the time should be taken in hours, and the price is given. You just multiply them, you get the cost of this. But the important trick here, he said, just the fan is on, the heater is off. Okay, now let me show you my work. I have done this. Let me show you. Okay, the important thing is only the fan is on. The cost is equal to power, but the power should be in the kilowatts, and the time should be in hours, and the price of which is given. So 200 watts, why I'm dividing with 1000? Because I want to convert it into kilowatts. So 200 divided by 1000 multiply 12 multiply 35. So the answer will be 84 cents because the price was 35 cents per kilowatt hour. So 84 cents, if you want to convert it into dollars, you simply divide it with the 100. So it will be 84 divided by 100. And oh, sorry, I wrote $84. It is $0.84. Mark this mistake. This is $0.84. It's not $84. It's $0.84. Here I just by when I was writing I made a mistake. It's $0.84. $0.84.
Done, sir.
Muskan and Zainab, are you done with this comparison?
Yes,
Yes,
sir.
sir.
And you understand this also?
Yes, sir.
Yes, sir.
Okay. So let's move to the next question. Let's check the marking scheme also. The marking scheme says 84 cents. A1. Okay. So by this we are done with the question number 10. I hope that you have understood this question. Very easy question. Now we are moving to the next question. A crankshaft is a shaped metal bar that is part of a car engine. It is free to rotate about an axis as shown in the figure 11.1. When the crankshaft is horizontal, a vertical force F of 8200 Newton acts downward on the crankshaft at the point P. This causes the crankshaft to rotate. The distance between the P and the axis of crankshaft is 0.050 meter. So, but it's very simple. This story might look difficult to you, this diagram might look difficult to you, but the actual thing is very simple. Actually, what is happening? This is the pivot, and here I have a point P. Here I am applying a force of 8200 Newton, and the moment arm from this pivot is 0.050 meter, and he will ask you to find out its moment. You see, the question number A, first part, state what is meant by the moment of a force. It's a two-mark definition. The moment of a force is the product of force and the perpendicular distance between the line of action of the force and the pivot. Moment of a force is the product of force and the perpendicular distance between the pivot and the line of action of the force. It's a two marks definition. I have written this answer as well. Let me show you my answer. And then we will check from the marking scheme also. Product of force and means the moment is the product of force and perpendicular distance between the line of action of force and pivot is called moment of force.
Done, sir.
Bete, you are able to. Okay, so we are. Let's
Yes,
check the
sir.
marking scheme quickly, and then we move to the next question. He says force multiply distance. If you just write force multiply distance, you will get only 1 mark. But if you write force multiply perpendicular distance from the axis, you will get the 2 marks. So I hope you will always write in such a way that you will get the full marks. Okay, the next part is the crankshaft is horizontal. Calculate the moment of F about the axis of the crankshaft. He wants you to find out the moment. The force applied here is 8200 Newton. and the moment arm or the perpendicular distance from the pivot or axis to the line of action of the force is 0.050 meter. Just apply the formula of the moment. Put these values. It's a 2 mark question, and you will be able to find out the answer. Let me show you my work. Moment is equals to F multiplied D. It will be 8200 Newton multiplied 0.05 meter. The final answer will be 410 Newton meter. 410 Newton meter. So let's check from the marking scheme. Marking scheme also says 410 Newton meter. Muskan and Zainab, are you done with this numerical?
Yes, sir.
Yes, sir.
Okay. So we are moving to the next question. He says sorry. The question is the the size and direction of the vertical force F acting on the crankshaft at the P remains constant. Explain why the moment of F decreases as the crankshaft rotates through a small angle. Try to understand. Very technical thing. You know this crankshaft is rotating. This crankshaft is rotating. The direction of the F remains same. But this crankshaft is rotating. Try to understand. Let me try to explain. Maybe my video shows up in the screen or not. I don't know. For example, when the crankshaft is like this, the force is here. So the perpendicular distance between the pivot and between the axis and the line of action will be maximum. The moment R will be maximum when the crankshaft is horizontal. But when it rotates, then when it rotates, the direction of the line of action of force remains same. So the perpendicular distance between the axis and the line of action of the force will decrease. When it will rotate, when the crankshaft will start rotating, the direction of the force will remain the same, but one thing will happen: the perpendicular distance between the line of action of the force and the axis will decrease. It means the moment arm will decrease. Although the force is same, but the moment arm decreases. That's why the moment will decrease. It's a little tricky concept, because when this rotates, the line of action of the weight is still the same. The direction of the force is still the same. So the distance between that line of action and the axis will become smaller. The moment arm will become smaller. That's why the moment will become smaller. I have written this answer. It's a little tricky thing. It's not an easy concept to comprehend what I'm talking about. The answer is very simple. It says moment arm becomes smaller. That's why the moment will decrease. Moment
Sir,
arm will become smaller. Let me show you the marking scheme. He says the perpendicular distance reduced, force not perpendicular. Only a component of the force is perpendicular. So the perpendicular distance or moment arm, we also call it, that will decrease. That's why the moment will decrease. Have you written this? Are you done with this question?
Yes, sir. Yes, sir.
Okay. It's it's little difficult to understand the concept of especially this third part, the actual concept. But the answer is very simple. Now, the force F on the crankshaft at the P is exerted by a metal rod connected to a piston. The piston traps high pressure gas in a cylinder. So here I have a high pressure. Here we will have fuel that will burn, and due to that, hot gases will be produced. So here the gas pressure is very high. So when the gas will burn here, it will produce hot gases. The fuel will burn basically, and that will push this metal rod downward, and that is rotating the crankshaft. This happens in the engine. Now you see, his question is the force of 8200 Newton acts because the high pressure gas pushes down on the piston. The air pressure outside the cylinder, the pressure or atmospheric pressure is 1 x per 5 Pascal, and the cross-sectional area of the piston is 0.0067 meters square. Calculate the minimum value of the pressure of the gas in the cylinder. You see, this this the gas, the pressure of this gas has to overcome the atmospheric pressure, plus it has to provide this much force on this much area. It has to provide this much force on this much area, plus this gas pressure has to overcome the atmospheric pressure also. So the pressure, the total pressure inside here will be equal to the atmospheric pressure plus the pressure of this much force on this much area. So it's a 3 mark question. Calculate the minimum value of the pressure of the gas in the cylinder. The pressure of the gas inside the cylinder has to overcome the atmospheric pressure, plus it has to give the pressure which is that force by area. Let me show you my work. I've done this. So pressure which is inside the gas of the gas inside the cylinder, that will be the atmospheric pressure plus the pressure which is exerted on that piston. So the pressure which is exerted on the piston will be F divided by A. The atmospheric pressure is 1.0 x per 5, and 8200 Newton force is acting on the 0.0067 meter square area. So I will calculate this. Both the pressures are there. Simply add them, and the final answer will be 1.32 x per 6 Pascal. 1.32 x per 6 Pascal. So the pressure inside that gas, the gas which was inside the cylinder, that pressure needs to overcome the atmospheric pressure, plus it needs to provide the pressure to that piston.
Done, sir.
Muskan and Zainab, do you understand? Do you understand this?
Yes, sir.
Yes, sir.
Okay, so we are moving to the next question. So the next question on your screen is, it was the 3 mark. Let's check the marking scheme also. Sorry, we have not checked the marking scheme. You can see that our answers are right. B, first part. Okay, let's move to the next question. He says, suggest why in practice the pressure of the gas in the cylinder is greater than the value calculated. The pressure which you just calculated, in real life the pressure inside the gas cylinder will be more than this. The reason is that gas pressure inside the cylinder has to overcome the atmosphere. It has to provide the force to the piston, plus another thing which we just ignored. In reality, there will be friction between the cylinder and the piston. You see, this piston is moving in this cylinder. Now, okay. Oh, sorry, there was something outside. So there is this piston and the cylinder, and the piston and the cylinder. The piston is moving inside the cylinder. So there will, in real life, there will be some friction between the piston and the cylinder. Okay. So due to this, so the we need to overcome that friction also. So it's a 2 mark question. Let me show you my answer. I have written this answer. There will be friction between piston and cylinder. Force is also required to overcome this friction. So the pressure inside the cylinder has to be greater than the value we just calculated, because it has to overcome the friction between the cylinder and the piston. Let me check the marking scheme. It's a friction exerting opposing force or between piston and the cylinder. So we have to overcome the friction between the piston and the cylinder. That's the answer. Muskan and Zam, you have written this answer?
Yes, sir.
Yes, sir.
Okay, so we are moving to question number 11, C part. It says the piston moves in the cylinder and the gas expands. State and explain what happens to the force F. When the when the piston moves, the piston moves, the gas will expand. You see, the volume of the gas will become larger. When this piston will move, when this piston will go down, here the gas, its volume will increase. When the volume will increase, the pressure of the gas will decrease. When this piston will go down, the volume of this gas will increase. So the pressure will decrease. So sorry. The volume of the gas will increase, and the pressure of the gas will decrease. When the pressure of the gas will decrease, then the force which is exerted on this piston by this gas, that will also decrease. Uh, this state and explain what happens to the force F. I've written this answer. Let me read. Okay. Pressure will decrease when volume will increase. So force acting on the piston will also decrease. We're talking about the gas pressure inside the cylinder and its volume and its pressure. Do you understand, Bete?
Yes, sir.
Yes, sir.
Okay. So let's
Sir,
see the
instead of
marking scheme. Marking scheme says,
sir, can we only write कि
you are
pressure decreases? That's it.
No, they are asking about
because
force.
he said, see, the
वो
one thing is
एक
very
mark का है
important.
ना सिर्फ.
Try to understand.
1 mark question.
Okay, so it's a one mark question, but try to understand this. State and explain. If you only stated, although it's a one mark question, if you only stated like you are saying, you have to state what will happen with the force, and you have to explain also why this will happen. So only stating will not work. You have to explain also. The force will
Okay, sir.
decrease. That's the statement. And why it decreases? Because the pressure of the gas has decreased. That's the explanation. Now you understand.
Yes, sir.
The word I highlighted is very important to understand that. Then we have the question number 11, D part. Explain in molecular terms why heating a gas at constant volume causes its pressure to increase. Very famous and straightforward question, but it is a 4 marks and a famous question. Explain in molecular terms why heating a gas at constant volume, the volume cannot change, the volume is constant. Why heating a gas at constant volume causes its pressure to increase. You know the pressure and the temperature, if the volume is kept, the pressure and the temperature of the gas, if the volume is kept constant, they are directly proportional to each other. So if you will increase the temperature, the pressure will increase if the volume is constant. Now, why? Why will this happen? When you increase the temperature, the kinetic energy of the gas molecules will increase. They will be moving faster. So their collision frequency, they will be moving randomly, and their collision frequency with the walls of the container will increase. Because they have higher kinetic energy, when they will collide with the walls of the container, they will exert larger force on the walls. In other words, we say they will hit the walls harder. So the pressure of the gas will increase. It's a 4 mark question and a very, very frequently asked question. Okay, so very carefully listen to these wordings and also try to write your own. Molecules of gas are moving randomly and are colliding with walls of containers. When temperature is increased, gas molecules' kinetic energy increases. They collide with walls more frequently. On collision with walls, gas molecules exert more force, or you can say greater force. Thus, pressure of gas increases. It's a four-mark question and a very, very famous question. Kindly write this answer and we will listen what you have written. Molecules of gas are moving randomly and are colliding with the walls of container. When temperature is increased, gas molecules kinetic energy increases. They collide with walls more frequently. On collision with walls, gas molecules exert greater force, thus pressure of the gas increases. Hurry up, girls. Let's check the marking scheme also. Marking scheme says any four lines. It's a four-mark question. Molecules collide with walls, hit with walls. 1 mark for this. Molecules move faster, kinetic energy increases. 1 mark for this. Molecules collide harder with the walls. 1 mark for this. Molecules collide more frequently with the walls. 1 mark for this. And greater force or impulse or momentum change on the walls, because we have not studied momentum in the O levels course. So don't do this one. Use the upper four lines. Muskan, you have if you have written your answer, you can read it. It's a 4-mark question. G. So what you said?
I have written that molecules of gas move randomly and collide with wall of containers. As temperature increases, kinetic energy also increases and molecules collide more frequently and exert more force on the walls of containers.
Yes. The molecules collide more frequently with the walls of container and they exert larger force. That's why the pressure will increase. Good, 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 good. It's a 4-mark question. And this question comes again and again in the papers.
Yes, sir.
Zanam,
Yes,
you have
sir.
written your answer? Would
Yes,
you like
sir.
to read?
Okay,
Yes,
sir.
we are listening.
Molecules collide more frequently with the walls of the gas container, and molecules will exert greater force, and the kinetic energy increases as the pressure of the gas also increases.
Okay, this answer, you see, this answer is right, but there is a problem. The problem is that she said that they will have the greater kinetic energy at the last. I think that when you increase the temperature, the kinetic energy of the air gas molecules increases. It should come first. Their
Okay, sir.
collision frequency with the walls of the container will increase. They, on collision with the walls of the container, will exert greater force on the wall. So answer was right, but its order of the sentences, that was not. Okay, so make them good. So I think this is enough for today. And today, my dear students, we have done work. We have worked on October, November 2011 2-1 paper. This is a theory paper. We call it paper 2. This paper is from zone 1. Today in this session, we have worked on its section B. We have solved question number 9, question number 10, question number 11. And I have tried, and my students have also tried to do the best. We have checked the marking scheme, we have already written the answers, and we have tried our best so the best concepts can reach you. If you are watching this video and this particular video is helpful to you, it's helping you to improve your concepts of physics and your practice for the upcoming CAIE exams of physics. Kindly like this video. Also send me a comment. Also subscribe to my YouTube channel. And also suggest these videos to your other friends. Because you see, you don't have to pay any money. You don't have to go to tuition. By just watching these videos, you can have an excellent supervised paper practice at your home. So, everybody, thank you very much. And it was a pleasure working with you people. So, thank you very much, everybody. Have a good day and God bless you all.